so just preliminary checks. Please let me know if you're not able to hear backbenches. Is it audible? Is it clear? Are you able to follow? Great, good.
Barely audible.
Barely? Oh, damn. All right. Okay, so hello all. I'm Sid Ramesh. Been coming to this meetup for about 2 years now, and it's a great meetup, one that I make time for every month. And I've been able to meet a lot of great people. Greg Pesby first, and of course Doug Toppin and John Kennedy, Peter Larson again. People who have inspired me to volunteer for this presentation today, and I'll be talking about AWS Lambda. So, before I start, I wanted to ask a few questions. How many of you are new to AWS? Okay. How many of you have worked with an EC2? Okay. How many of you have worked with S3?
What?
S3.
I thought it was successful.
How many of you have worked with SNS? Okay, so these are 3 services that we'll be using along with Lambda. So we'll be doing some demos. I'll be going into some code, pretty simple Python code. So even if you're not, if you haven't worked with Python, if you're new to Python, that's still okay. The code is written in English, and that's all Python is. It doesn't require you to know any more than just simple English. But if the presentation is getting difficult for you to understand, if I'm not speaking clearly, if the code is not comprehensible, please do not hesitate to stop me and I will respond. Okay. So I wanted to try AWS Lambda because we have had a lot of AWS topics, like Peter Larson just mentioned them a couple of moments ago. We've had Doug Toppin do AWS EC2, CloudFormation. John Kennedy has done, I want to say AWS CLI, and he's done one other topic, slips my mind. So I wanted to add to the shelf of AWS presentations here. And I'm pretty much following the legacy of Doug Toppin by doing a Git pitch. I must say it's a pretty easy and user-friendly repo. So you have trouble? Okay. So the presentation that I'm making, that I've used for this talk, is Git pitch. And this is a extension. I'd like to say this is an extension of GitHub. So the presentation is in Markdown. The whole thing is in Markdown. And Git pitch is rendering what I've written in Markdown into slides. So if you want to see how the actual presentation looks like, it's a simple Markdown file. And Git pitch is actually turning all these into neat slides. The other cool feature about Git pitch is the branching. So I don't have to go linear like 1, 2, and 3. I could go 1, 2, sub 2, sub 3, sub 4, which you'll see in a moment. And I also wanted to, before going ahead, I just wanted to point out that in the Meetup website, I have put the links for my presentation and also the repository that I'll be using today. So if in case you want to follow along, and by the way, how many of you are planning to follow along? Okay, so you should have the code up in the repository. All right. Cool. So I'm Sid, and I work as a data analyst at Carson Solutions. We are a federal contracting company, and we do enterprise modernization, which AKA is AWS for us. And the goals of the talk is that by the end, you should hopefully know what AWS Lambda is. What is it used for? How can you use it? So you should be able to, I'm hoping, make it a part of your infrastructure or think of using AWS Lambda if you're creating new architectures. So with that in mind, intro to it. Okay. So AWS, I want to say, if you haven't heard of AWS and you plan on working in the IT industry, it's pretty rough. It's pretty difficult times. HRs want to know if you know AWS. Like that's the first thing, even before they want to know your name. So AWS is, like Peter said, it's pretty impressive. And they have a whole, I want to say more than 100 services. And it's just impossible to keep up with AWS, but I do try. So Lambda is just one of the many hot topics that AWS has to offer. And in case you haven't heard, Lambda is from the serverless phenomena. And we'll be going into what the serverless is in a moment. But at this point, just know that we have come from what was in 2005 only a data center world to in 2010. I want to say by 2006, Amazon introduced S3, and then we had the virtualization revolution, and then the cloud, and then the Docker revolution. And Docker, I want to say Docker was relatively unknown back in the beginning of the decade, like 2011. And by 2014, Docker got a lot of spotlight. And by 2016, most deployments is containerized. So that's the sort of revolution that Lambda or serverless is also having in the industry. And like I said, I'll be using Python 3.6. Okay. So for a pedagogical definition of what is Lambda, now Lambda is a event-driven, purely compute resource that allows you to deploy code directly and not worry about infrastructure. So what it means is no EC2s. You don't have to worry about patching. You don't have to worry about security updates. You don't have to worry about the cost that comes along with the EC2. You don't have to worry about pretty much even networking. What subnets? There is a security component to Lambda, but it's not as huge as it would be if you were using an EC2. And all this comes from the serverless idea. Now, serverless stands on the shoulders of Docker, or should I say the shoulders of containerized deployment. So containers allowed for multiple environments within a single box. And running Dockers allow you to run your code and not worry about anything else. And that's the idea which is at the core of the function as a service phenomenon. So you have the infrastructure as a service, a platform as a service, and now a function as a service. So function as a service really is, serverless can be called function as a service. That's what I wanted to say. And Lambda is AWS's offering of serverless. And we'll also be looking at one other example.
Question.
Yeah. Question?
No. Sorry. Question. Oops.
So what you see here is a open source framework for function as a service. Now, AWS has Lambda, Google has Google Functions, IBM has their own OpenWhisk, which I think they have lent to Apache now, and you also have Azure Functions from Microsoft. Now, you also have the same thing going on in open source world. And here is the serverless framework, which is a abstraction. It's platform agnostic. It's on GitHub again. So if you'd want to know what exactly is going on, if you want to know an approximation of what is AWS doing in the background when you're pushing the code, then it's a good idea to go through this GitHub link. All right. So, what's the advantage of using Lambda? Like, why is it so important? Why is it so hard a topic that everyone seems to be talking about? It's simply because anything that you can use an EC2, anything that you do on an EC2 in your infrastructure, you can do with Lambda. Or I want to say most things that you want to do. And that's where we'll be touching on the limitations of Lambda later on. So if you're running, let's say, an ETL job from your EC2, you could pretty well use Lambda for that. If you're using an EC2 for, let's say, connecting to different services and basically having a bunch of functions which connect to services like from an S3 to an SNS or from an S3 for application. You can pretty much use Lambda for that. So is that the only advantage? Well, the bigger advantage is cost. So, cost benefit is pretty much the the showstopper for a lot of people, which makes AWS Lambda hard to ignore. You get billed in milliseconds. So get that, milliseconds. So that's 6 zeros after a point of a second. Okay. So just to give a comparison, now a T2 micro is going to cost you somewhere about 1.6 cents per hour. But think of it. So even a 1.6 cents per hour, if you run it for a whole year, and let's say if you have 4 T2 micros, which is like an average sized enterprise infrastructure, which a lot of people use, you're still looking at north of $600 to $800. Now all of that is really reduced to, like, I don't know, with using Lambda, we have had a bill of about $16 for the past year at the place that I work. So that's pretty impressive, right? You get the same job done, except at a lot lesser cost. So that's one of the bigger advantages. You get billed, of course, in 100 milliseconds, and that's the step that AWS uses. So really, even if the millisecond as a unit is 10 to the power of -6, you get billed at like 10 to the power of -4. So that's still a lot of zeros before you get to a second. In my mind, you can get accomplished a lot before you are even looking at 1 second. So now we'll be looking at the
Is that supposed to be milliseconds or microseconds?
milliseconds.
Because what you have on the number is a microsecond.
Damn. I wanted to. I don't know how that missed.
It's
Good
just
catch.
zeros, doesn't matter, right?
Very good.
Well, I apologize. I don't know how they got slipped. Anyway.
I think the point still is true, right? Unless
The
you're-
point is true to the extent that
Still
you
a
still
lot
have
of-
zeros, except it's not a lot. So now we'll be looking at the dashboard. Okay. So AWS has a plethora of services, which I don't even know if it's 100 or if it's more than 100. I just want to say a lot. And the way you find Lambda is in the compute section. You go to Lambda, and then it should display the dashboard, which it does not. It takes me directly to the functions. But if you don't have any, for those who are following along, this is the page that you would see. Okay, a page where you can create functions. So what do we have? We have something that says full account of concurrency. We have something that says code storage, show some space here. And then we have a number of functions. Now because I've created functions, I have a number called 8. Now if you have not used it at all, you should see 0. And this here says my usage. Now because I was doing some testing, it shows some graphs going up and down. But if you haven't used it, you should pretty much see 0. And from this dashboard, before I get into a demo, I wanted to first talk about the CLI option. CLI, as Doug Toppin has pointed to multiple times in his presentations, you can do anything in the CLI that you can use the dashboard for doing. So instantiating EC2s, creating VPCs, putting objects into S3, and you can use CLI for Lambda as well. You can use, you can even programmatically automate Lambda, and that's the idea, is to have a CLI where you can automate, you can schedule the automation, you can also hand it over to someone as a technical knowledge transfer, as opposed to having a huge document with a lot of screenshots. And while CLI is a very important option, this talk will not be covering CLI. I'll only be doing dashboard because that's, well, the talk is 101, and it's a lot more easier to keep it that way. So, now to start our first function. So how do you do that? And AWS has some options for you here. You can author from scratch. You also have blueprints that AWS is going to provide, and that blueprints pretty much comes in with some baked connections, depending on what you want to achieve. So if you want to connect to S3, it gives you an inbuilt S3 connection. If you want to connect to SNS, it will give you that. If you want more permissions, well, you can ask for that as well. It's also runtime specific, so you can be like, I want S3 and Python. You could put that and it'll get you. We'll be looking at blueprints later, but initially we'll be looking at how to do a completely new function. And AWS also gives you a serverless repo. So later in the talk, we'll be looking at what's called the serverless application model, which is now gaining a lot of traction in the circles that I'm aware of. And that's what I like to call Lambda++, but we'll get there when we get there. And so before we can go into that, let me try to see if I can create a function. Okay. And for those of you who are following along, you can get all the code here. So that's a simple function that we'll be looking at right now. You can copy and paste the code, or you can just type it in, whichever works. So now this is the function that I already have. Oopsie, let me just close that. Create a function. Okay, author from scratch. And here you can give. So a lot of you who have used S3 would know that AWS would require a unique name. You don't have to do that for Lambda. You can just put anything. I'm going to put novalug demo 1. And the runtime is going to be Python 3.6. And I'm going to choose an existing role, and that's going to be Lambda basic execution. So we look into what goes into the making of a role in about 3-4 slides ahead. Right now you can just choose Lambda basic execution, create a function, and then you have this screen that says novalug demo 1. Okay, so this is your console. This is what I like to think of as my console. Here you have a couple of things going on. You have some functions here, and then a designer which offers you some options, and then you have a Cloud9 integrated right into your browser. So if any of you have used Cloud9, it's a great service. It's a IDE, not exactly an IDE. It's actually I'd like to say it's a CentOS container which is being deployed on the back end. It gives you the same Linux feel. Okay, while I won't be able to go to the root from the Cloud9 browser that I have in Lambda. If you were to open a Cloud9 separately, you would pretty much be looking at a CentOS type of Linux environment. I'm very careful to not use the word IDE. It's not an IDE. It does give you some autocomplete functions, but that's about it. You have to pretty much compile the function before you can get any return. So now here I have, let's see, a tab that says import JSON and then some stuff. Now I don't need any of the stuff here. I'm going to delete. I'm going to hit tab, and then I'm going to do. Let's do something. What would you like?
Anything but hello world.
Anything what? I didn't hear.
But
Hello. No hello world.
Okay. Hello.
How about a counter?
Hello, lug.
he changed it a little.
Okay, how about this? Hello, no. I like it. Okay, so notice that the moment I made the change, it saved. Okay, and that just happened instantaneously. And before that happens, you notice an asterisk, and once it saves, that disappears, but you still have to go and save the function. And before I do that, I need to configure a test event. And that's how you let the Lambda console know what's the output that you're looking for. Okay, so right now I have a hello world template. Let me call it. Okay, and I'm gonna leave the JSON. Oh, what happened? I'm gonna leave the JSON the way it is, and I'm gonna go down, create. Oh. All right, so now I'm gonna hit save. I'm gonna hit run or test, and then something happened. What happened? Oh, cool. I got some execution result. So Cloud9 offers you the execution result right in the bottom. Usually what it returns is the return value. Like if you were declaring print statements, you won't be able to see that right here, but you can see the whole thing if you go to the top and click on details, and then here's the CloudWatch log that was created when the function ran. And here you can see the return value, which is hello novalug, and then you have some summary information. Now it's my favorite pastime to actually look at the summary information every time I run some function, because that kind of tells me something of what's going on in the back end. Now you see the duration, and then the build duration. That always catches. So even if the duration was 0.29 millisecond, I've been billed for 100 milliseconds. And that's pretty much the Amazon step. Okay, so it could not even be 1 millisecond, but still Amazon is going to bill you for 100 milliseconds. And it's going to step through like that. So it's always the higher ceiling. Okay, so if you were, let's say, a 1,001 point something, it's going to bill you for 1,100 milliseconds. And the resource is configured and max memory used. So here's where the event-driven pure compute thing comes into play. I have a couple of options here. Basically, the max time for execution and then the max memory that I can provide. And that's what you see here. Now we'll go into more details on when you would need to customize max time. And for this function, for the hello world or hello novalug lambda, you have only 21 MB worth of memory used. So here's another, so that tells me that even the basic, like the most basic in Python is going to have a minimum of 21 MB. Now, the max memory used is subject to the runtimes. So if you were using Java, it's most likely it's going to be upwards of 21. If you were using Go, I'm guessing it's going to be lesser because that's a cloud language. And then here you have some request IDs, start, end, report, and all the request IDs. So the test event that I configured did not offer any more than just the key value. So I just wanted a hello world, so that's what I had. But you can pretty much have your JSON be modified to capture as many details you'd like. Yeah, go ahead.
Could you explain what an event is again? So it's performing a function once.
What an event is?
Yeah.
Okay, so the question is, what's an event? Okay, so in the next demo, or I think 2 demos down, you'll see what an event is. But simply speaking, you would want Lambda to run when something happens.
Okay.
So let's say, and I mean that's pretty much the demo, is that if I upload something to my S3, I need to get a text message. Okay, so how is that going to happen? Well, SNS actually, I want to say S3 gives you the option to directly send you a text message. But in this demo, we'll be using Lambda to do that in Python. So the whole point of Lambda is that it takes away the EC2, which is in between, for like complex infrastructures, and you can just put a Lambda in, and when something happens, then I need to get it. It's pretty much like if then, if this, then that, the if logic. So that's the advantage of Lambda. And moving on. I'm not gonna click on the CloudWatch log.
It's like a message.
Wait,
I think another way to explain what an event is it's like a message. One service is sending a message over the internet, either broadcast or to a specific function, and then another service like Lambda gets the message, like a letter, opens it up, looks at it, and then does something.
sure, that could be said as the effect of the event, but the event is the cause. So when I upload something to S3, that's the cause which shoots the effect. Yeah, go ahead.
Yeah, so messaging is, there's actually a secondary thing, messaging that's available, that's absolutely a lot different than how events are handled. So when people think messaging, they may think of MQ or other
SQS.
services like that. Event is different from that in this sense.
Oh,
So SNS is different from SQS, right? And there's a big difference. The idea, the easy way that I look at an event is, I mean, if you scroll down a little bit so that we can see the designer, that will, okay. So typically under designer, it's a trigger. So think of an event as a trigger, right? You're out there and as Sid said, something happens and there's a reaction based on that thing, and it's called an event. So what we've done, or what Sid's done here, is he artificially created an event. When he gets down to triggers later, maybe it will become a little bit clearer. It's one of those things, there's a definition, you can read through the definition, it may or may not make sense. But are you doing you're gonna do an S3?
Yeah, I'm going to do an S3
So,
to SNS, and I'm
Yeah,
actually
when he
going to
does
do
the S3, it may help click a little bit on what an event is. So let's give it an example or two. But messaging is different in that you typically have a pub-sub type relationship, and that's not
That's not
sort of
what's
is how
going
it
on
is,
here.
but it's really murky as far as in the Amazonian way, events and messages are very different.
Let's crawl first.
Can this thing be used to control the Internet of Things?
Yes.
Yes, IoT.
What's exhibit?
IoT, Internet of Things.
Yeah.
Yeah, so I want to say that you can, if not directly through CloudWatch, have a trigger hook to your hook to the Lambda console, and have a piece of code.
Look at the second trigger down.
Just gonna say, it's right up there.
Okay. Yep. So there you go. I haven't used IoT, at least in the Amazonian way, in the words of Greg.
So, for instance, if you have an Amazonian or an Amazon button that you push, basically what ends up happening is it's generating an event, and then Lambda will get it and be able to process that for you. Just like if you have Alexa and you talk, it's a similar type of workflow.
Yep. So moving on. Well, the takeaway of this demo, of the first, Hello Novalug demo, is that you can run functions, okay, and that's all you're bothered about. You're not bothered about anything else. You basically define your program, and then hit run. Okay. Now, we'll be going into much complex demos, which should hopefully, if there is any gap fill. So let's go on here. Looks good. All right. So now is the second demo, and so I pretty much didn't talk about the levers and controls that you have here, except for the test. You have two things here, which says one is configuration and then is monitoring, and then you have some stuff going on here, and then you have a lot of stuff going on. So in this example, we'll be looking at the function that we're passing. So if you're used to Java, that's your public static void main. Okay, and in Python, that's your main function here, and by default, the handler function should have the context and event. Okay, and they both do two very distinct, very important things. And and here we'll be looking at an example, at a context example. So remember I said that the Cloud9 integration is baked into the browser, and it's pretty much a Linux environment with except that you don't connect to the instance, it's just in your browser. So that's exactly what the context and the handler function thing is all about. So here you have the lambda function, which is the name of the function. So it doesn't always have to be lambda function. You can have it named different, except that you have to let Amazon know that. So you have to let AWS know by changing the name of your function. So I'm not going to change the name right now, but you'll be looking at another use case where you don't have, if there are dependent libraries and AWS does not offer them, then you can pretty much upload the package and have AWS run the whole thing. And if you have a different name for your function and a different main method, then here's where you're looking to change. Now, this is the handler information, which is the name of the function and also the name of the method. Now, in my case, the handler the main method is also called lambda handler, and that's by default, and I just prefer to keep it that way, so I've not changed it. And we have some code here. So what's this code about? This code is simply calculating some numbers. Okay, so all it's doing is a power of a power of a power, like m to the power of n to the power of n. So that's what this is about here. That's what I have, except I have it 3 times. And that's to demonstrate that you would have, depending on the complexity of the program, increasing time or increasing requirement for execution time. And so that's what we'll be looking at here. If we go to the grid pitch. Yep. So that's the example. So what happens if you have something running and it takes more time? Okay, how long? Well, you can go to a max of 5 minutes. That's the max that Lambda has. And that's the biggest, that's like one of the biggest limitations that I've heard people complain about Lambda is that it'll take, your function is not supposed to take more than 5 minutes. Okay, if it takes more than that, it's gonna fail. So why is it taking so long if the execution is in milliseconds? Well, it depends on code complexity. And that's the example. So I have a simple function, which is here, and I have something here. So it's basically calculating the arithmetic logic, and it's printing the result. So it's going to print the result and the time difference. So the way I get it is I use the context parameter. And of course, AWS being AWS, they have a user repo of APIs that you can use. And the way you use that is by calling the go-to. Oh, I don't even have it here. Okay. No, then you don't need it. So in this example, the way I'm getting the time is through the get remaining time in millis, which is a default function, and you can pretty much just attach it to the context using the dot notation, and that's going to get you your remaining time for that function. So any problem with what's going on in the code here? Is it clear? Okay. So I already have my test event. If you want to look at the JSON, it's pretty much, it's the same hello world function that we had. I'm gonna do a test here, and you'll see something happen. Oh, okay. So, well, a lot of zeros, right? That, you see a lot of zeros here? That's because that's 10 to the power of 5 to the power of 7. Yeah, that's right. But I think I did something which I was not supposed to here. I think that's okay. Let me try to do it this way. Okay. So I have an error message. Why do I have that? Well, I have it because the function was not able to execute within the time it was given. Okay. And that's the whole point of this simple demo, is to demonstrate that you can actually have, depending on code complexity, time actually kills, and really does in Lambda's context. So,
Because it was 1,000 milliseconds.
yes,
Where did the 5-minute thing come from? I'm sorry, I missed the
sure. So,
line there.
in the console, in the Lambda console, you have in basic settings. I was wanting to first get an error
Oh,
message.
you set it down to 1,000?
Yes.
Okay, got it, I'm sorry.
So I was wanting to first get the error message and then explain what's going on.
My apologies.
No problem. So in basic settings, here's where you define the memory and the time. Like space-time, computers are about memory and time. So the minimum that I can for time is 1 second, and the max is 5 minutes.
It's a lot of milliseconds.
That's a lot, exactly, that's a lot of milliseconds. Except, it's not enough for a lot of enterprise level operations, like say ETL for example, which usually runs for hours. So, and that's an easy application which could be ported out of the EC2, but because of the time constraint, it's not as wide yet. I do know some people who have a hack for that though.
Question. I saw a hello alpha file above your, what's that file for?
Okay, beautiful. Well, I was actually rehearsing this presentation before I would actually, dare to climb the stage here today. And the way that happened is that I, remember the, it's a Cloud9, it's a Linux thing baked into the browser comment. I can pretty well just click on the plus sign here, do a new file, and write comments, Okay, now I can also save this. How do I save it? Let's do So that's what is going on. And you can also have functions here. You can have, you can use it as a log if you want some tabs. And this is the same idea that says, I don't, just one working console is not enough. I want more. And that's exactly what's going on here. So the function failed because the complexity or the amount of functions that I'm using was not able to execute completely. So how do I change it? I pretty much increase the time limit or the timeout that I have. I'm going to save it, and I'm going to execute. It did take more than 1 second, probably more. Okay, and I have some information here. So the best way you can look at the output is by going to the CloudWatch logs. And that's just what it is. They won't give you a drag down where you can just scroll to see the whole message. It's just not it. So for the function that I have, the first return statement or the first print value, the total time that it took is only about 4,945, which I want to say is like 55 milliseconds. And then the second one, if you notice, pretty much ran instantaneously. Okay, so a simpler function, so it didn't take a lot of time. The third one did take a lot of time. It took like 1,300 milliseconds. So that's where the timeout function comes in place. If I were to limit that only for 1 second, it would fail. And that's pretty much what you're looking for. Depending on code complexity, you have to make sure that the function is one stateless. The scope of the function should be within the Lambda definition, and then it should also be within 5 minutes. So these are two very important things to keep in mind. Okay. So that's the, go ahead.
When you state the stateless within the Lambda function, what exactly are you
So no file uploads, like some things which require you to maintain state.
Every call starts and stops with the same state.
Alright.
Like, you start with with the same data, it doesn't get data from anywhere else, and it ends, and then when it's done, it's completely gone.
So all its input is in the event.
Mm-hmm. Yes.
So does that also include, say, if I have to make a HTTP request or something in the function, is that possible?
Yeah, I mean, HTTP request though, API gateway is like one of the other core ideas of the serverless application model. But AWS, I want to say most of, or all of AWS is REST, and that's the stateless anyway.
So like if I want to make an asynchronous HTTP call, so something that Lambda would help me in doing that.
Yeah, so you can do asynchronous, you can also do synchronous. We'll get to that. But yes, invocation types. You do have asynchronous, you have synchronous, you have a push and a pull, and you do have that option. Except the scope of the function that you're defining is limited to the code that you have with it. Again, it won't hold any information with it. All right. So here, the big takeaway of this demo is the context information. Okay, so that's where you store time. And now we're going on to the event information. So demo 3. You can go here, click on that. So pretty much even in this demo, I don't have a trigger. I'm just going to run it by the test function. And the code looks like this. I have something called the OS-N1. Okay. So for those who know Python or who have used the import OS library, you would realize this is an environment variable. And I can pass environment variables even on the Lambda function. And this is where the CLI option gets interesting. So you can have a big chunk of code and have all the important data points parameterized, and then pass it as an environment function, environment variable. So when you're automating infrastructure, that's your input, and you can pretty much say, for example, instantiating an EC2, you can change the EC2 instance type, you can change the memory allocation, you can change pretty much all the things that define an EC2, all the attributes. So, but in this example, we'll be using the dashboard, and here's a simple environment function where this is a key and this is the value. Okay, it's a JSON input like all the other AWS functions, and in this code, I'm going to be using the I'm going to be first importing the library called OS, which is operating system. And then I'm going to be storing the value for the key that says hello. At this point, I have what's up. But let's change it. We can change it to something else. Let's say cool. How about that? And I'm going to save this. And when I run the event, it's going to get me what I have stored in the event. So notice that I don't have the actual print statement defined within the function. I'm only passing the key, and the value is going to be imported from the key. So that's the example here. Let me first, before I run it, this is how the JSON looks like. Now you would notice that this JSON is different from what we had previously. Previously we had only a key value and it was just repeated 3 times. And here you have something that says message, no message, and the message just says this is novalug. So this JSON structure that you see, this is the input for the test. Now when you create a trigger or when you create an event trigger, the data which is passed to Lambda is also going to look like this, except it's going to be much more comprehensive. So that's where the logging comes in. So you can pretty much log any details you want. So for now, I'm just going to cancel that. And I have my function. It's going to say message to be printed. And it's going to get whatever the message says, which at this point it says this is novalug. And then it's going to print the val or the value that I have for hello, and it's gonna end. Test. Cool. So I have some information here. I'm gonna go look at the log, and in the log I have some info. That has cool. So the takeaway is we have used a JSON structure which has passed in a value for the key, and Lambda was able to import it. Lambda was able to basically use a operating system library and take the value from there and do what we wanted, which is to print. So cool. In my learning of Lambda, and I'm no expert, I don't use Lambda for my daily job. I'm just wholly invested in learning AWS because that's what my company is all about. Learning about context and event pretty much, sums the 101 of Lambda. And from now on, it's more about how do you use different events and different triggers, and how do you use the parameters which you have, which is the time and the JSON, to identify what's going on. Yes.
Is the editor scriptable?
What?
Is the editor that comes with the Lambda console scriptable?
The editor meaning, where did that go? This one?
Yes.
Yes.
You write a command procedure that has a bunch of edit commands and automate things, and otherwise you have to do a lot of typing.
I'm sorry.
It's not an ID.
Did you write a script with edit commands to do some complicated changes that would otherwise involve a lot of typing?
He wants to know if you can customize your editor.
Can you customize it to have
Like an IDE,
Like
like
an
autocomplete,
so
macros.
So I want to say there could be a way. I haven't used it. I haven't explored it to the extent that I would want to turn it into a editor, and that's where. So when I look at this, what this looks to me like is like a Vim on a CentOS. Okay, so it's pretty much like I'm doing a Vim on Lambda function, and it just shows me the Vim editor, and I'm doing whatever, and I'm running it, and I'm exiting out of the Vim and running the
But I'm
Python.
assuming you can use Git or whatever else to put in the code that way, right? Make it possible.
Probably.
So-
I've just not explored.
So click on, under edit, under edit, go to keyboard mode. So there are some options, it should pop up, yeah, so there's some different options. By default, it's going to, so for instance, if I do an open paren or an open bracket or double or quote or whatever, it's gonna fill in the line or the second half. But
looks like
it's not fully scriptable, I think that you want, but there are some modes that you can put it in that's gonna make it more familiar.
Yeah, insofar in my experience that I've come across, the auto completion is the only feature that is close to an IDE that I find in this editor here. Any more than that, like say if you're importing a library, it doesn't automatically show all the methods that you can call in that library. It also does not show if you've made an error until you run it, and then you have to have multiple print statements to see where the execution failed, things like that, which is not which is not yet an IDE.
So, I mean, couldn't you just run the, use whatever editor you're comfortable with, your current IDE for whatever language, Python, whatever, and use, the CLI to deliver the code to the function, and that's your iteration, testing and such. Instead of developing it right on the screen, use your editor to write whatever complex stuff, and then just use that output.
So, using Lambda with AWS CLI, is that your question?
Yeah, in other words, you can deliver the code with AWS CLI, I think. Seems to do everything else.
I think what he might be asking is, if you can open up a terminal in here and use VI or Nano or Emacs for that matter, you don't have to be within the editor here.
Sorry, I could have said that.
One of the menu choices up there is open terminal, I think, something like that.
Yeah.
You'll just open a shell right into the instance, and you're able to run whatever you want inside that.
I think I can actually do that right here.
Right, you can do it there or in the above one as well.
Yeah, I was more just thinking you deliver the function, just almost like uploading it. I thought.
That little plus sign, right, keep going to your right, go one, no, I can't. Go down, go to the tab where your editor is right now. and you'll see that will keep going, just hit plus. No, I'm sorry, go to the tab above that, not the execution. Right there, right below, right there. Now, keep going to the right, keep moving right, down, right, there. You should be seeing open terminal. Oh, maybe you can't do that with the Lambda console. When I'm using Cloud9 directly, you can.
I wanted to say that.
That's interesting. I
Yeah.
did not know that.
Yeah, so, you know, this is another difference between the Cloud9
Yeah.
and what you have here, is that you can also go to the previous levels here. So you're pretty much stuck at you know, what it seems like is var/task/ the folder that I'm running in. So that's, I want to say you should be able to configure a output or an input from CLI, which throws a Lambda function and which gives you an output, but I don't have an answer to, can you run terminal right now?
I have a question. So can you deliver a function from, say, like your Linux desktop or like, you know, a VM that you're running? Can you just deliver the function straight from there?
Yeah,
Or does
sure.
it
That's
have-
where the CLI comes in. Right.
Right.
That's so if you want to, you know, say you don't want to log into the dashboard and you want to schedule a Lambda event. Okay. The way you do that is you first create an IAM and you know, get yourself the secret key, the access key, and make sure that you have the permissions right with the being able to create Lambda or being able to create trigger an S3, and then you can pretty much use AWS CLI, which should have all the required API documentations and do what you want. So that can be done. It can also be, I've also seen it being programmatically done. So I know it can be done, except we're going to limit the dashboard only. All right. So that completes the third demo. I'm pretty happy. Okay. So now we are moving into the territory of event triggers. So before I would want to do that, I just want to give a small example of what could be done, of just like one example of what could be done using Lambda. You had a question? No. Okay. And here, in this demo, you see two things here. Previously, it was only the Lambda function in the CloudWatch logs. Now there is also the SNS. So SNS, for those who don't know, is simple notification service. You could use that for getting an email, getting a text message, getting a JSON, getting, I want to say even HTTP stuff, but I'm going to be using the SNS here to get a text message, I think. So what I have configured. Yep, that's the text message, and that's my phone number right there. And so if those of you following along, you know, if you would want to test for it yourselves, you could pretty much copy the code from the repo. Just be sure to change.
Say with your phone number?
Yeah, absolutely. I was actually about to keep this here just so that, you know, it would buzz when I get the.
Why do we get so many damn text messages?
Yep, totally. So the way this thing would be executed is by having the role that lets me do that. Okay, so the road to Lambda goes through the IAM, and this is by far in my learning curve to getting some understanding of Lambda. IAM took most of the time. Okay, so that's because I'm using Python, and Python is something easy. But if I were using say Node.js, and I would assume Node.js would probably take more longer. But IAM is a very important concept as far as Lambda is concerned. So here in execution role, I have something that says choose an existing role, and then it's SNS publish. So to get to see what we have in SNS. Let's see. So the JSON structure that you see here, this is basically a collection of key and values. And all it's saying is that when the lambda is triggered, it's going to have an output, and the effect is to allow, and it's going to create logs, it's going to put logs, and then for the SNS resource that I have, it's going to pull in the Bodo client and send me a text message. Here's the example. So I'm just going to quickly go to see the JSON structure. So this is going to be, so this is my input, which is the same hello world, and I'm going to just have my mobile here placed. And any questions on what's going on in the code? Is it clear? Do you have any questions? So just to breeze through, I'm creating a new instance from Bodo 3 client. Bodo 3 is a default for anything to do with Python and AWS, and I'm creating the instance for SNS and just calling the publish method, and I'm just putting this text message, and I'm going to do text. Okay. Did it run? It did. It should run. It says you should get a text message. Let's see how long it'll take. I'm going to put it here. So this is a pretty simple demo. I just wanted to put this in because why not? It's easier for people to visualize the output when they have something coming to their mobile as opposed to going into the email. And that's what we'll be using for the other examples that I'll be having coming up next. So here is a simple but very powerful example. Now this is where the event trigger, okay, took about a minute, but it's here. Let's see what it says. Hello from novalug. So, hello from novalug. I'm sure you can't see it, but that's what it says, trust me. So, in this demo, I have an input. Now, previously you only saw the test event giving the input. The test event would have some JSON, which would trigger off the lambda, that would run the function, that would get me an output. Here I'm actually going to have an S3, which I have configured to give trigger the input, trigger the lambda function, and that's going to run the code and get me an output. Okay, but before I do that, I want to click on S3. Okay, so that gives me the S3 information. Notice that I can't see anything else. I can't see the basic settings. I can't see the execution role. All that is taken off. I can only see the novalug S3 lambda. That's also that's the name of that's the global name of my S3. And it says enabled. So when an object is created, I should see the lambda invocation fire. So let's look at the code here. Okay. So the code looks like it has a lot of lines. Trust me, it's not. It's pretty simple. It's just a lot of print statements that I put again and again, just so that I would know what's happening on lambda. So to begin with, I'm importing the JSON library, the Bodo 3, and the OS. Well, OS is not necessary here, but I just have it as legacy. And then a print command, it says starting invocation, and the main function. So before I would go deeper, let me go JSON file. Here. Oh, okay. So this is an example of the trigger that S3 is going to send. That's the object. This is how it's going to look like. And let me copy. JSON parser is a very useful tool. I'd highly recommend this for anyone who's using JSON. Helped me a lot to understand what's going on. Here you can actually see that I have records, which is my first object, and that has a lot of key values. Okay. I have the S3 bit of information, which has the object, the tag, the key, and all that. I have a response element. I have some user identity stuff going on. So basically, I have a lot of key values here, which is structured as a array and element, which is JSON structure, and that's what I'm using to code here. Okay, so the event of I'm looking to get the name of the bucket, and that's what I'm doing here. Okay, so I'm looking to see S3 and the bucket. So records the first object, and then in S3, and then in bucket, I'm looking for the name. So that is what is going on in the first statement. And I pretty much have the same thing repeated again and again. Okay. So I want the bucket, I want the region, and then I want the object, and then I want a text message that says that you have a new object uploaded to your S3. That's all it's going to do. I'm going to upload, and it's going to send me a text. So here is an example. Any questions as to the progress that we have made thus far?
Sid, I never knew that we had the ability to choose the region that the data goes to. I thought it just went into the cloud.
With AWS, you can actually choose where your resource is hosted.
Very cool.
So the next demo, you're going to see the object replication. So AWS has, or S3 has the coarse replication function, where you can have an S3 in Northern Virginia, and then I'm going to have an S3 in Northern California, and that's the point of the replication, is that if there is downtime on one region, you would still have it on the other region. And instead of doing it using coarse, we'll be looking at a Python code which would basically copy the object from one bucket, put it into the other bucket, and send a text.
Let me add a little bit to that. There's a really useful thing to be aware of associated with S3. S3's namespace is global, its storage is by region. What that means is when you put something in S3, it has a unique name, the full path of its unique name. You can see it at any region around the world that can see it. That does not mean that that other region can access it if the region it's stored in goes down. And what Sid just talked about is a really important thing to note along this line. If US East were to go down, for example, US West could not see the items that were stored in the US East bucket. So where that comes down to some important aspects of this is that when you create a bucket, it's a good idea, always suffix the region to that bucket name. Bucket A-US East 1, for example. Then in US West, you could create bucket A-US West 1, and you could replicate from US East to US West. You could let it replicate automatically via the cross-region replication that Sid mentioned a moment ago. And you have a common naming convention at that point. So whenever you create a bucket, if you create a bucket called A, if US East were to go down, US West would not be able to see it. And if you wanted to duplicate bucket A in US West, if you've got it called bucket A in US East, you can't create bucket A in US West because the namespace is global. You have to give it some other name. That's why it's a good idea. Always consider suffixing your bucket names with a region name, because then you can replicate them and have a common naming convention around the globe. And it's something you don't see that mentioned much. In fact, it doesn't even show up as a best practice. But it's a really good idea to do that out of habit. Sorry, I didn't mean to interject and say this is an important
No, that's great.
And it is possible you can have regional outages or issues. It is not impossible. That's where disaster recovery and replication, all these things come in and become very important to be aware of.
Yep. So, again, I need to have my, let me first go click on my, okay. All right, for those of you who are wondering what's going on here, notice that I have my phone number hashtag, which is basically commented out. Instead, what I have here is a email setting. So in SNS, I've created the ARN. I've created the following SNS, novalug S3 to SNS topic, which I have configured with my email. Any of you who would want to, who have not used SNS, want to see how that works, No? Okay. So it's pretty simple. You just have to create a topic and then you subscribe to the topic. That's the pub sub of the SNS. And it's and all I've done is to put the ARN for the SNS resource. And I'm just calling the SNS resource when I'm initiating the publish method. And I'm passing that as the parameter. I have a subject and then I have a message. For those of you following along, you can put your own email and hit test, and you should see your message and your subject pop up. So, which is why I have, you should get an email message here. Now, we can, okay. So, this is a interesting input here. Now, I was up until this point using only the hello world JSON input, but you can actually have a lot of different input styles. And AWS actually gives you all these inputs. Now, also notice that you can change JSON once you have a template to add as much details you want. In this example, I'm going to be using the S3 get object. Now, this is a Amazon provided JSON. That's the input. And it says, because it's a test example, it says happy face, but I'm going to be uploading a different object, and that's what I would expect to see for the name of the object. The key is the name. So a key in the JSON here is the object in S3. So that's the object that you upload. So I'm going to cancel out. And in this example, I'm not sure if there's any value in looking at the email. We could probably do that. So this is a example object. I'm going to upload this to my S3. Come on. Great. So let me try to see if I can open the email here. I don't know if it's a good idea, but let's try and make it work. Cool. New object in my bucket. The name says scene.jpg. So that's the notification, and that's the example. I uploaded an object to S3, and Lambda sent me a text message. Now, of course, you don't have to use Lambda. You could just simply configure the S3 to send you a notification. But I just wanted to demonstrate the event for a simpler example. So one of the real world use cases that I've seen is for replication of objects, or say for storing logs. So this is something which I know the team next to where I sit uses. They use a lot of Lambda functions, and one amongst their list is to use Lambda to storing RDS logs. So RDS is or Amazon is gonna take away logs after 5 days. But what if you want to build an archive? What if you want to know what happened a month ago? The way they've come around solving this problem is by using Lambda. And they basically use a Lambda to take all the logs created for a day and shove it to S3. And that way they have all of it, and the whole thing runs on Python. And this is one example, but we'll be looking at the example that says So the first part of the code is something that you have already seen multiple times in this presentation. You have, up until this point, just values being stored. The name of the bucket, the object, the region maybe. Yep, I have it. Okay, so so here's the name of the source bucket, and here I have defined, I have explicitly mentioned the name of my target bucket. And as you can see, it says novalug duplicate bucket. So my source bucket is called novalug source bucket. Okay, so this is my novalug source bucket, and this is the target bucket, which I call the duplicate bucket. And as you can see, in the source bucket, I have nothing in, but once I upload something to the source bucket, it's going to go to the target bucket. Now notice one other change. This ties into the different regions thing. So here I have Northern Virginia, our own Sterling, Virginia, and then here I have Northern California. Okay, so I'm going to take the object that's put on the first bucket, and I'm going to shove it to the US West region. I think it's US West 1. Yeah. And then I'm going to get a text message. So this is the extra stuff that I've done. Course does not send you a text message. It doesn't send you anything. The function that I have here, or the function that you see, it's going to send me, it's going to first duplicate, and then it's going to send successfully duplicated. So I know that the function has run. I don't have to go to the log to check to see. Let's see. To explain what's going on in the code a little bit here, I'm using a API that says copy object. Okay, that's the dot notation. I'm instantiating the S3 using the Portal 3 client. Let me go back here. Yep. So here's my instance, and then I'm using the API that Amazon provides to copy the object. So here's where I would like the IDE feature come in that if I have the Portal 3 client being imported, it would be nice to have a drop down of what methods I have as I keep typing, like in Spider or in the other IDEs out there. But I don't, at least not yet, we have the option. So the copy object has the parameters, which is the source bucket. Oh, sorry. The source bucket, the object, and then the target bucket. Okay, so it's I have not defined this function. I'm just using what AWS has, and I'm storing the response in this variable. And we can look at how the output of this function looks like in the CloudWatch logs. But just to keep sense of the time, I just wanted to wrap this demo so we can go to the next one, which is more interesting. And here I have something that says state. Now notice I'm going to be using the state information here to send me to log the success or failure information here. Okay, the state is pretty much the REST API. It's your standard success, the 200 value that you have in the HTTP method. And I look to see if the state is 200. If it is, I'm going to get a success. If not, I'm going to get failure. Okay. And let's go here. Cool. So on the source bucket, I have an object uploaded. And in the target, I should see something populate. Nothing happened. apologize. I had a different event configured. That's the test.
While Sid is doing it, so I'm gonna point out, this is a good example of how to react to events and write photo code, for example, to do it. But S3 has something that I was talking about earlier, it's called CRRS, Cross-Region Replication Service. That will automatically replicate from one bucket to another bucket with a different name. There's that suffix, with a different name. That's why it's a good idea to suffix region names on the bucket. Yep.
What about rollover? East Coast goes down, you have a replicated copy on the West Coast. Is there a mechanism to cause the replicated copy to pick up the functionality?
When you say pick up functionality, I mean, the objects are duplicated. As stuff goes into S3 in one region, it can be replicated to another, and it
Right,
will
you
in
have
real
an
time.
application that's going to the copy of the East Coast, and now it has to go to the copy of
Can
the
you
West
maintain a
Coast.
single namespace to go to two places?
You'd have to do that with DNS. You'd also have to have resources allocated in the other region, meaning if US East is down, EC2 is down in US East, obviously. So you'd have either an active situation where you have EC2 running in US West as well, or create an environment US West. That environment would reference the namespace for that region, if that makes sense. So in other words, if you had code in South America, if you had some other region around the world using an object in US East, and US East went down, it would have to recognize that it was no longer able to get that, and then reference the object in the US West namespace.
But the process of changing over is manual.
No, this would be
You'll have
automated,
each, so
certainly not.
each data, it's like two different data centers. So the code in having data center east refers to the data in data center
Sorry, so
east.
just to make sure you know, there is a CRRS, there is an automatic CRRS.
And then you have the
S3
code in data
has
center
CRRS,
west refers to
cross-region
data center west.
replication,
And
that
then
will
you
do
just-
what you're doing right now.
I come from mainframe,
Yeah,
part,
make sure you do
and
that.
it's automatic
Sure,
failure. You can take your system off.
I just wanted to be
One thing
wanted
goes
to
down,
have the lambda
you
functionality.
request
Yeah.
automatically.
Yeah, it's a
right
good
from
working
the-
example of how to do it, yeah.
So that's not,
So
that's a different topic that can be done, but that's
the
not.
cross replication
You, the
was pretty much
developer,
the example that I wanted to,
that
you know, because that's
Yeah,
what I've
there are
seen
types
a lot of
of
people.
things.
Right. So, sorry for this brief interruption. So, if you can pay attention here again. This is my source bucket, and this is my target duplication bucket, and I have two objects here. Now, I just quickly tested what's going on with the function, and I had a different test event configured, and that was the reason why I was not able to get the duplication happen. So I'm going to put, let's say, the JavaScript logo on my source bucket. I think that's the source. Okay, I'm going to upload, and this is my duplicate bucket, and voila. So that duplication happened because of lambda. In my example, okay, you also don't have to use lambda, but that's that's what the code here is doing.
So, how do you debug? I mean,
How do I debug?
if you're looking at your original piece of code, and you probably don't need to use debug for most of those. But what happens when it's a little more complicated and you go, I did not expect that result. How do you deal with that?
So the way you deal with that, the way I've dealt with that is a lot of print commands, and that's like the checkpoint, and you have all the print commands logged in the CloudWatch log. So that's the whole point of the even more elaborate and exhaustive, I should say. The CloudWatch logs can get as detailed as you want them to be, and you pretty much click on the log and you view the latest. And in the next example, which is going to be more exciting, you would see the different outputs. And I had to have a lot of print statements to make sure when I was debugging, I had to have a lot of print statements. And even here, I do have a lot of print statements.
Look at say is X-ray. AWS, look at X-ray for a Lambda. X-ray is a
Is a
instrument
HTTP.
for code and gives you the debug opportunity. So You wouldn't X-ray.
breakpoints and stuff for watches and
Yep,
things,
well, okay, absolutely.
Cool.
I've heard of X-ray being used in the context of API gateway and for blue-green deployments. I'm pretty sure you can use it for S3 as well. But
It's debugging your Lambda code. X-ray is perfect for that.
but isn't X-ray more for HTTP request calls and the network traffic?
No, this is the AWS X-ray service. That will absolutely give you debuggability.
Did not know that. Anyway, so the way I've done is by having a lot of print commands, but of course, you have as many ways, as many stars you have in the sky. And notice that we have not yet taken a look at the SNS response. Let me just go back here really quick and let me refresh. And I'm expecting to see some emails that say, I've got an object in the name of the object. Okay, so I got the latest 2 minutes ago, and it did also let me know the name of the object. So this is the simple, cross-object replication demo, which I have seen in terms of real-world use cases. This is what Lambda is most often, I want to dare to say, is used, is to copy things, is to take logs, is to replicate objects, is to basically, when something happens, copy, or something happens, do.
Randomly curious, if you were to set up an SNS publish to where you copied like an image to S3 and then had image texted to you through the publish, like the image, the body of the object that you upload, would you go, does SNS use MMS to let you like get an image?
Could you use an MMS? I don't think.
What format? You look on your phone, the thing it just sent you, it'll tell you what the format is.
Well, it's more, instead of looking at the phone, I can say that when you create a topic in SNS, the options that it gives you is pretty much like text options. So you have either an email as a text or a SMS as a text. So
is the content longer than 140 characters on a text message?
I have not tested it, but I want to venture to say you can. I've seen some really long text messages.
How do you apply this to data science?
Data science?
Yeah.
You don't apply this to data science. This is infrastructure stuff. This is infrastructure stuff. For data science, the only example that I can say is if you have, say, DynamoDB, which is a NoSQL database, and you have streams being created through the API gateway, you can use Lambda for concurrent functions, and pretty much, keep pushing all the streams that you have from DynamoDB and push it into Kinesis. Okay, so that's an example. But that's not something Lambda can do. It's only going to be the middleman to get stuff in. But I also want to venture to say that Lambda can also be used standalone. I'll talk about that example at the end. So now, because we are all infrastructure folks, we'd like to deploy, and we'd also like to automate deployment. Here is the final demo. And this is the deploying of an EC2. You don't have to use Lambda for that again. You can just use an auto scaling group, and you can set the minimum instance that you would want. You just take it 1, 2, 5, or many ever. But I'm using Lambda, and we'll look at what's going to happen here. So this, so the function that I have, what it does is it basically, yeah, I don't know why I'm not able to get all the code in a single screen, but if you can look, it's not any more than verbose declarations of the attributes of an EC2. The region, the instance type, the security group. That's what I have basically defined on the top. And notice, because we are all, we have a lot of friends here from Red Hat, the AMI that I have here is a Red Hat AMI. Yeah. And this code is going to launch a T2 micro with the Red Hat operating system. and then it's going to install Apache. And we're going to look at that as an example of how you can use Lambda to not only instantiate, but also install stuff on the back end. And I'm just going to press go, and then I'm going to get the IP. I'm going to put it, open a new tab and put it on. And we should hopefully see an installed Apache, at least the front page. Now, I'm using this example to invite you all to think how you can use infrastructure deployment. You can pretty much run anything you want in terms of shell commands right in Lambda. You can also use Lambda to deploy some, to take in from Ansible or Chef. So that's also a possibility. And so the input that I'm getting here is the state input. Okay, and I want to have a EC2 deployed at any given point in time. And if by mistake the EC2 that I have gets terminated, then I want Lambda to recognize that the EC2 is terminated and launch the instance, install the whole thing, happen instantaneously. So let's look at the test. The input JSON. The input JSON. So in this, I'm pretty much declaring the state as terminated because this is my test. I'm just gonna use this to send in a message that says the default is a terminated state, so I want Lambda to launch the instance. So that's what the state message at this point would have. So when I'm going to look at the CloudWatch, that's what I'm expecting to see. And then these are just some parameters that need to be passed. It's a necessity argument. It's a necessity argument for the run instances method. So the image ID, which is the AMI, which is an Amazon machine image, and then is the instance type, which what I have right now is a T2 micro because I'm cheap, and then is the min count and max count, which is the number of EC2s that I want, and it has. So I don't want more than one, which is why you have one in both the parameters, and then the instance initiating, and then the instance shutdown behavior. So when I say terminate, it should basically terminate. I don't want any snapshots. I don't want any root volumes being disconnected. It should basically simply terminate. And then this is the key pair name that I'm passing if I want to connect using the SSH. In the example that that we'll be looking at, you won't be connecting using SSH. It's just simply going to install the website, and you'll see the result. And if it does not notice any terminated state, it's just simply going to say it's all good and finish the return the instance ID and finish the function. So that's what's going to happen. Okay, we have about 15 minutes. So let's see. This is how my EC2 looks like right now. Cool. And this is my, this anymore. I don't think this anymore. And there we go. I'm gonna test. Cool. So this thing says the instance ID, and just remember this F2C98 for me, please. Let's go here. I'm gonna refresh F2C98. Happened on its own. I was not required to go through the CLI. I was not required to go through the dashboard for instantiating the EC2. Lambda took care of it for me. Now, of course, in production deployments, you wouldn't have Lambda. You would simply have an auto-scaling group and let AWS take care of it for you. But this is an example of what you can do for infrastructure deployment. Now, the real-world use case that I've come across for this is taking EBS snapshots. That's not Lambda, by the way. Taking EBS snapshots, taking logs, reverting security groups. These are some examples that I've heard of, and that's the infrastructure use case. But at this point, you're really looking at infrastructure as code. So Lambda being used as infrastructure as code, kind of like your Ansible. Or using Python for stuff that you would do using Ansible. So let's look at some details here. Okay, so this thing took a solid 1.5 seconds. And then the total memory that was used was only 35 MB, impressive. And then I have some information here. Let me just click on the CloudWatch to look to see what's going on. So in the event that you don't have an SNS configured, your only resource to look at the print commands or to look at return functions is to go to the CloudWatch logs. You have the monitoring tab to know if the invocation happened, and we'll look at that in a moment. But I'm gonna keep this tab open. I'm gonna go to EC2. Hopefully my Apache has been deployed by now. Let me just go here and let's see if it runs anything. Hopefully it should. In the meanwhile, I just cheated before the meetup started, and that's what I was doing with my configuration, is get the IP address added to my security group, and that's a small piece of information which needs to be in before you can see the connection go through. Okay, so this is still struggling, but while that's happening, this is how it would look like. Okay, now you have a different IP address here. Of course, that's because I'm going to say within 2 minutes you'll see the same page with my new IP, but this is how this is the Apache page. So the EC2 was instantiated, and I had the Apache installed, and ta-da, you have the website, or an example of a website. Now you could also have pretty much the whole script that you would have to install a WordPress website baked right into your Lambda, and it would do it. But I'm going to stop at installing the Apache for now.
Also happens within 5 minutes.
Yeah. And let's look to see if the instantiation is complete.
You can also have Lambda tickle your security groups too, right?
Yes, that's the other real world example that I've come across is if there is any wrongful implementation of security group, you can use Lambda for reporting. Okay, so let me just go here now because I want to make one more point before I end my talk. So I'm not going to wait for the presentation for the Apache page to appear. Maybe another time. Cool. So this is using this is using the IP address that I got for the instance ID that Lambda created. It took, I want to say, at least 5 minutes for the whole thing to happen, but I'm impressed. It did all itself. So again, if you would want an SNS, you could send, you could put the SNS information in, and it would send you that. Now notice that I'm just gonna right click instance state terminate. Cool. So the moment you see the instance state as terminated, I'm expecting to see the same block of, I'm expecting to see this repeat again here with a new instance ID. Okay, and EC2 is here going to provision another instance and also install the Apache. While that's happening, let me just go for a brief moment, look at the code here. I think this is a simple piece of information that I jumped. So this is the install script that I'm having run once the instance is up. Okay, I'm basically doing a yum update, like that's our ritual that Red had, and then I'm doing an install HTTPD, which is the Apache, and then start the service. That's it. But you could have that as elaborate as you would want.
run that within the Python program?
Mhm. So, here's my values that I'm storing into the variable here called init script, and in user data I'm just passing the init script. Okay, so I'm basically passing all these shell commands in the user data variable here, and AWS is going to do it. So let's see if okay, so this here says terminated. I'm going to go here and do a retry. Nothing is found. Oh, wait a minute. Did I have it disabled? Darn it. Oh boy, I apologize. I had it disabled. So I'd have to test again, and I'd have to terminate again, but this will be quicker, I hope. So this is another easier feature for you to have your CloudWatch logs triggered when you want them to trigger. You don't have to have them on all the time. You could basically turn off when you think you don't need them. I don't want the EC2 running when I'm not using it, which is why I disabled it. And now because I'm having to do a demo, I'm going to enable it. I'm going to do the same thing and hit delete, and hopefully do something. Okay, so I have another instance here, and notice this is the test input that I gave in. It was not a automated terminate and instance creation. This is something that I had to manually run the test command here, so that I would pass the input function. And let me just do this again and terminate. It's going to take about 2 minutes. And in this while, I want to quickly go to the monitoring tab. Okay, so this is the last piece of information which I want to leave you all with, is that you don't have to always rely only on the CloudWatch information. You can go to the monitoring tab, and it gives you a nice dashboard with a lot of time series graphs, and you have the invocations here, with basically the times, the number of times you had the invocation happen, and then the duration, and some other information. So, for the gentleman who asked about the asynchronous calls, now Lambda gives you an inbuilt concurrency option, okay, and it gives you about 1,000 concurrency options. So you can invoke Lambda 1,000 times per second, if I'm not wrong. Don't quote me on that. And that's going to be the last setting that you will have here. So the concurrency option is where you have the invocation types come in, which is the asynchronous and the synchronous. If you want the order to be preserved, that's when you would look at asynchronous. And the real world use case that I can think of is the DynamoDB streams log processing, where you are bothered about the sequence of the event. And that's when you would have a concurrent invocation of Lambda coming into picture. If not, I've really not seen a lot of people use this option. So that's the throttle command that you see here at the top of the screen is a stop that you can apply for concurrent executions. But you're only bothered about it in a stream processing type of a scenario, which is not often. I don't want to say that. Okay, so what happened here? Okay, so this thing says terminated. I'm going to refresh. Hopefully something is clear here. Oh boy.
There are unsafe changes?
Gosh darn it.
Live demos, always.
Well, if I'm past the if I'm past 12 o'clock, I'm going to expect you all to believe what I say. But anyway, the other points that I wanted to make very quickly is, let me see if this thing is triggered. that's again something that I triggered right now. And you will see that appear right below. And in the meanwhile, let me go quickly trigger limitations. Yep, so basically the time limit, the scope, and you can't really know what's going on in the container that the function is being deployed in. That's one, in some people would say that's a big limitation, but that's one of the limitations. And this is just things to keep note of in case you would want to have this in your repo. I just put that in a slide. And one other aspect that you can have included in your architecture is the VPC, which adds a layer of security. And here is, so some of the use cases, of course, is taking the snapshots, using Lambda for ETL, and deleting snapshots. Now, notice I've put a standalone application here. I've once come across a gentleman explaining his use case where he used just Lambda to change a PDF scan file into a text file. So he basically just uploaded a PDF scan file into his S3 and uploaded the whole thing and uploaded the text file into an S3. Okay, and it did the optical character recognition. It did the the text parsing and all that all itself. And the way he did that is by the moment the time would get closer to 5 minutes, it would automatically launch another Lambda and take on from there. And so he basically had like one Lambda launching another Lambda, launching another Lambda. And as a standalone application itself, instead of thinking of it necessarily as an infrastructure company. So.
Any wonders I has $1,000 bill because of the runaway Lambdas.
Well, interestingly, he was pretty happy that he was only looking at two-digit numbers as opposed to 4 digits. So I'm going to terminate this, terminate that, and hopefully something happens. And in the meanwhile, here are some resources that I used to learn myself. You can just click on all these things and take you to those pages. Amazon has very exhaustive documentation, and that's one of the places that I would go look. And you can also look at the other resources here. For those of you guys who do not know or may not know, you all can go, if you're residents of Fairfax, get a library card from Loudon, and that will allow access to Linda. Okay, and that's a pretty useful resource, by the way. I use it a lot for my life. Okay, so this thing is shutting down. Hopefully it will happen within a minute. And let's see if I can retry it. Okay, now false alarm. Right, so.
Was there anything you found that Lambda won't do that you wish it did in your travels?
Something to think about with Lambda, by the way, is the next thing to look at once you start using it is step functions. Because Lambda is called a microservice limited to 5 minutes or whatever. You probably want to have multiple things go on, orchestration of events. Step functions are the way to do that. And step functions are free.
Yep, so serverless application model and step functions. These are what I would broadly call as Lambda++. But in the event you may have missed noticing what happened here, the previous instance got terminated, and right on its place, Lambda did its job and launched the new instance right back in. And that happened without any manual intervention. That happened on its own. And that's all for today, folks.
All right, thanks, Sid.
Thank you.
I want to thank John Kennedy and Doug Kaufman, of course, and Greg Presby for giving me this opportunity and for inspiring me for making this presentation. Hopefully it has added value to you all, and hopefully you can try to think of ways to using Lambda. All right,
Quick shout out to our sponsors, Ridgeline for enabling use of this facility, and Red Hat for the refreshments. Is there-
SG2.
Is anybody hiring? Great, anybody looking for work? All right, feel free to network. So we will get our October, November speakers posted up on the meetup. Watch for that, and as Peter mentioned earlier, we're always receptive to your ideas. So thanks again for coming. Enjoy your Saturday afternoon. Thanks, Sid.